This is number 58 from Chapter 5. A 2-meter-long pendulum is released from rest when the support string is at an angle of 25 degrees with the vertical. What is the speed of a bob at the bottom of a swing? Since the length of a string doesn't change, we don't need to consider its string potential energy. Therefore, we only need the kinetic energy and the gravitational potential energy in the equation of the conservation of energy, which is written as kinetic energy plus gravitational potential energy at its initial state equals the kinetic energy plus the gravitational potential energy at the final state. Here I indicates the initial state when the string is at a 25-degree angle with the vertical, and F is the state when the string is vertical. The initial kinetic energy KEI is 0 because the bob is at rest. The initial gravitational potential energy given by PEGI is negative mb times g times L times cosine theta. Plugging in the numbers, we have negative mb times 9.8 meters per second squared times 2 meters times cosine 25 degrees. At state F, the kinetic energy is 1/2 mb/Vf squared, where Vf is the speed of the bob. The gravitational potential energy, PEGF, equals negative mb times g times L, which is equal to negative mb times 9.8 meters per second squared times 2 meters. Plugging in the individual terms in the equation of the conservation of energy, we have 0 joules times minus mb times 9.8 meters per second squared times 2 meters times cosine 25 degrees equals 1/2 mb/Vf squared minus mb times 9.8 meters per second squared times 2 meters. Canceling the mass of the bob, mb, on both sides of the equation and rearranging it, we have 1/2 Vf squared equals 9.8 meters per second squared times 2 meters times 1 minus cosine 25 degrees. And then you will have Vf equals square root of 2 times 9.8 meters per second squared times 2 meters times 1 minus cosine 25 degrees. And this will ultimately be 1.9 meters per second.